Welcome to Module C, where we will be talking about rational functions. So here's your first rational function. And it is 6x plus 18 divided by 2x squared plus 10x plus 12. Now, right beneath it, I wrote an equivalent expression that gives me an equivalent graph. And we've been doing that since the polynomials unit. So what did I change? Well, I basically factored the polynomials in this rational function so that I could view a few more of the features. In case you didn't notice, a rational function is a function that's a ratio. It's got a numerator and a denominator. That numerator and the denominator are both polynomials. That's what makes a rational function. So here's 5 quick points to keep in mind. Number 1, always factor your rational functions. Why? Well, because the factors, anytime we factor is because we're interested in finding zeros. These zeros give us key information. For example, the 0 of the numerator is -3. That means that this function could have a 0 at -3. And as it turns out, it doesn't, but there's a specific reason for that. Many other functions, you'll find that whatever your 0 is in the numerator will be the 0 of the function. This function does not have a 0. So it's a possibility. Now, if you look at the zeros of the denominator, -2 and -3, we have some action happening there. These are going to be the discontinuities. One of these is a whole, one is a vertical asymptote. All right. If I actually pay attention to my graph here at x equals -3, you'll find, or x equals -2, excuse me, at x equals -2, you find that you have a vertical asymptote. In other words, this line that is being approached on both sides of x equals -3, but never touched. All right, that's because of that -3 in the denominator. Then if you look closely, all right, for x equals -2, right, or x equals -3, I should say, when I try to trace this graph here at -3, surprise, surprise, boom. That's actually undefined. -3 has a hole right there. So this is an undefined point. -3 is not part of the domain. Neither is -2. Those two are called discontinuities, and they're found with the zeros in the denominator. Short story for that is a denominator cannot be equal to 0. When a denominator is equal to 0, you have an undefined fraction. So point number 2, holes. Kind of tough to spot. I just traced one. How can you spot it? How can you know which one of these discontinuities is a hole? Well, you notice that x plus 3 is a factor in both the numerator and denominator. That tells you that you are going to have a hole at x equals -3. Point number 3, horizontal asymptotes. You notice that this rational function levels off on both ends. And we wonder, what is it leveling off to? It looks like my values are approaching 0.3 or something like, well, 0.29. All right. If I look at the degree of my function, I have a linear function divided by a quadratic function. I have a few rules for that. All right, in points 3 and 4. If the degree of the numerator is larger, the function is going to have a slanted asymptote. Here, the degree of the denominator is larger, so the horizontal asymptote is going to be 0. In other words, if I zoom out of this, I will find that these ends are getting closer and closer to 0 on both ends. So that's the end behavior. As x approaches -infinity, the function approaches 0. And as y approaches, as x approaches positive infinity, your y values also approach 0. So that's the horizontal asymptote. Now you'll find that when the degrees are the same, you just need to look at your leading coefficients, but I'll let you discover that with a few more examples. Last, the y-intercept. You notice that the y-intercept of this graph is 1.5. All right, if you look at the leading coefficients, 6 and 2. Now, was that my y-intercept? Let's see. No, not 6 and 2. If you look at your, not leading coefficients, I apologize. All right, if you look at your constants, the coefficient of your constants, 18 and 12, right? They usually serve the purpose of y-intercepts for their respective polynomial functions. For a rational function, we're just going to take the ratio of those. 18 divided by 12 is the same as 3/2 or 1.5. So that's a little info on x-intercepts, y-intercepts, vertical asymptotes, holes, end behavior, et cetera, et cetera. Rational functions are awesome.